We have seen how to alter the flow of a program by using if, for, and while. So we can have conditional execution, we can have repeated execution. So the last ingredient in our typical Python program is a function. So what is a function? A function is a group of statements which performs a given task. So of course we could write the function code as part of the main program, but by isolating it, we can logically separate out units of work, and very often these functions are called repeatedly with different arguments. So they constitute a unit of computation which can be used repeatedly from time to time. So we define functions using the def statement as we have seen informally. So the definition defines the name of the function. In this case, we have just called it f. Usually we would give it more meaningful names. And then it says that this function takes three values as inputs. So these are called parameters or arguments. So the first one is called a, the second is called b, and the third is called c. And within the body of the program of the function, a, b, and c will refer to the values which are passed to this function for a given call. Within a function, we might have a statement like this called return. So the body of the function is indented like we had for if, while, and for. And the return statement, if it is encountered, it says at this point the execution of the function will end and you will get back to where you called the function from, returning the value in the name v. So this could be any expression, right? So we could just have return of a constant or return of v plus 1 or whatever. So when we call a function, we have to pass values for the arguments. And this is actually done exactly the same way as assigning a value to a name. So suppose we have a function like this, which takes x and raises it to the power n. So let's just look at the function just to understand what the code is doing. So we assume that the value of the answer is 1. And now for as many I as there are in the range 0 to n minus 1, we multiply x into answer. So we get effectively x times x times x n times. Right? So each time we go through this loop, we multiply one more x, and finally we return the answer that we have got. Now, the way we would use this function in our code is to write an expression of the form, say, power 3, 5. So obviously what this means is that 3 should be used for x and 5 should use for n. And we would then run this code with the values x equal to 3 and n equal to 5. So actually you can imagine that when we run this code, it's as though we have this code inserted into our program at this point, preceded by this assignment. So the assignment basically says set the value of the name x to the value passed by this, namely 3, set n to 5. So this assignment is what takes place effectively when you call a function. And since it is an assignment, this behaves very much like assignment in the regular case. In particular, the same rules apply for mutable and immutable values. Remember, we said that when we write something like x equal to y, okay, if it is immutable, that is the value in y cannot be changed in place, then we copy the value and we get a fresh copy in x. So the value in x and the value in y are disjoint. So this is if it is immutable. And if it is mutable, we said we don't copy, we share the value. That is, both names will point to the same copy of the value. So change in one will also make a change in the other. That happens with mutable things like lists. So immutable values will not be affected at the calling point in our case, and mutable values will be affected. So it's as though we are making an assignment between the expression of the name in the calling function, calling point, to the name in the function. So if the function modifies that name, the value of that name, if it is an immutable value, nothing will happen here. If it is a mutable value, something will happen. So here is a simple function just to illustrate this point. So the aim of this function is to update a list. So I give you a list which is called in this function L, and I give you a position, okay, which is I, and what I want to do is I want to replace whatever is there by a new value v. Right? So I get three arguments. L is a list, okay, and then I is the index or the position, and finally v is the value to be replaced. So what do? We first check that the index is a valid index. So we check that it lies between 0 and L minus 1. So it is greater than or equal to 0 and it is strictly less than the length of L. If so, what we do is just replace L of I by the value V which we have got, and we return true to indicate that the update succeeded. Now, if I is not in this range, then we can't do an update. So what we will do is effectively return false. So this is just to say that the update didn't work, and then the part of code which is calling this can understand that something went wrong, and presumably what went wrong is the index was not in the valid range. But just to illustrate what happens with immutable values, in this case we are also updating for no good reason the value of v to be v plus 1. So remember that v is being passed as a value to be put in here, and we are assuming normally that v would be an immutable value. So let's assume we call it now. So what we do is we set up a list of numbers, 3, 11, 12, and then we want to replace this 12 say by 8. So just for the sake of argument, we first set up a new name z called 8, and we say update the list ns at position 2. So remember the positions are 0, 1, 2, right? So update the list at position 2 by the value of z. And then we say update the same list at position 4 by the value of z. Now as we saw, if the value is 4, right, then this if will fail. So it will instead go here. Right? So this won't work. So it will go here. And what will happen inside the code is that v will be incremented. Now v has been copied from z. The question is, what happens to z? So as you would expect, after executing these 4 statements, because of this update succeeding, the value of z is copied into the list at position 2, and so we get the value 8 instead of the value 12 that we started with. On the other hand, if we execute this statement, then because this is an immutable value, the change in v inside the function doesn't affect z at all. So although v has been incremented from 8 to 9, z remains 8. Right? So this is just to illustrate that if we pass a parameter through a parameter a value that is mutable, it can get updated in the function. Okay? And this is sometimes called a side effect. So the function affects the value in the other program. So this is called a side effect. So a side effect can happen if the value is mutable, but if the value is immutable, then the value doesn't change no matter what you do inside the program. Now there are a couple of other points to note about this function just to illustrate. One is that we have here 2 return statements, return true or return false. The idea is that they indicate to the calling function whether or not the update succeeded. So ideally you should have said something like result is equal to update, and then check after the update whether result is true or false, because remember update will update the list or not update the list depending on whether the index is valid, and it will return true or false depending on whether the update succeeded. So by examining the value of whatever is returned, we can check whether the update we intended worked or not. So this is something which we would expect, but we have not done it. So this is just to illustrate that there may be a return value, but maybe the idea is the function will actually update some mutable value, so you don't care what it returns. All the work is done inside the function. So even though there is a return value, you are not obliged to use it. You can just call a function as a separate statement as we have done here. It doesn't have to be part of an assignment. The other thing is that because of this, there may be functions which don't return anything useful at all. A typical example would be a function which just displays a message like there was an error, or it displays some other indicative thing for you to understand what your code is doing. Now such a function just has to display something. It doesn't have to compute or return anything. So there may be no return function. So by default, what happens is that a function executes like everything else from top to bottom when it is invoked. And now if you encounter a return statement, at that point the function stops executing and you go back. On the other hand, if you run out of statements to execute, if you reach the last statement and there is nothing more, then also the function will end. So there is no obligation for a function to actually have a return statement. So a return statement is useful if the function computes a value and gives you back some result, which you will use later on. But you may have functions which don't have a return value, in which case you can either return some empty thing or you can return nothing and everything will work fine. Another point to note about functions in Python is that names within a function are disjoint from names outside a function. So let's look at again a kind of toy example which doesn't have anything useful to do. So we have a function which we call stupid, which essentially takes an argument and returns it, right? So it does nothing. But in between, what it does is it just, for no good reason, sets the name n to have the value 17. Now suppose we had in our program outside a statement which assigned the value 7 to the name n. And then we call this function. Now obviously if we say stupid of 8, then v will be also the input, so it will be v will become 28. The question is that while executing the fact that v is 28, the function internally set n equal to 17. So the question is, we have asked n to be 7, then we call this function, n became 17 inside the function. Is n 17 now or not? So the answer is that n is still 7. And that's because the n inside and the n outside are two different copies of n. So any name which is used inside a function is to be thought of as disjoint from the name outside, right? So the names outside are not visible inside, the names inside are not visible outside. Now this is not something that you would normally do because it's just confusing if you use the same name inside and outside. But sometimes it is useful to have this separation, because very often we do use common things like ij, k to run through lists, like ranges and things like that. And it will be a nuisance if we have to remember and use I outside and j inside and make sure that they don't interact. But since they don't interact anyway, we can freely use I and j wherever we want and not worry about the fact that we already have an I or a j outside in the calling function. One of the things that we mentioned up front was that a function must be defined before it is invoked. Now, this is a slightly subtle point, so let's just look at it a little more. So remember that a Python program is read from top to bottom by the interpreter. So when the Python program is read, it reads the definition of f but doesn't execute it. And notice that this definition of f has an invocation to g, which is actually later. But the point is, when reading the definition of f, g is not used. It's only remembered that this statement, which should be in a bracket by the way, just to be consistent. Okay? So this statement should be computed if I call f. So it's not calling f, it's just defining f. So I define f, then I define g. Finally, when I come to this statement, it says what is f of 77. So f of 77 will come here and it'll say, okay, f of 77 is nothing but g of 78, right? So that will come here, and it'll say g of 78 is nothing but 81, so it will come here. So 81, and then finally I'll get 81. So it's only when I execute the statement that f is executed. At that time, g has already been seen. So though we say a function must be defined before it is invoked, it does not rule out the fact that one function can call a function which is defined after it, provided that you use this function only after that definition. So this sequence is fine. Suppose we rewrote this sequence in a different way, right? So supposing we had the definition of f, then we had this statement, okay? So we have basically exchanged these two statements. Now what happens is that when the Python interpreter comes down this line, at this point it will try and call f. So f will try and call g, and g will say, well, I don't have a definition for g yet because I have not yet gone past this statement. Okay? So if I put this statement execute f before I define g and f requires g, then this statement will create an error, whereas this statement will not. So it's really useful if we define all functions upfront, because any interdependency between functions will be resolved right away by the interpreter and we don't have to worry about it. Whereas if we do this intermixing of functions and statements, then we have to be careful that functions don't refer to the later things which have not been scanned yet by the interpreter. So this is one more reason to put all your function definitions at the beginning and only then have the statements that you want to execute. A final point that we will return to later when we go through more interesting examples as we proceed in programming is that a function can very well call itself. The most canonical function of this kind, these are called recursive functions, functions which rely on themselves, is the factorial function. So if you remember, n factorial is defined to be n into n minus 1 into n minus 2 into n down to 1. So you take n and multiply it by all the numbers smaller than itself up to 1, and by definition 0 factorial is defined to be 1. So what we observe in this definition is that this part from n minus 1 to 1 is actually the same as n minus 1 factorial. So in other words, n factorial can be defined in terms of a smaller factorial. It is n times n minus 1 factorial. So that's what this function is exploiting. So there is a base case factorial of 0 is 1. And since the factorial of negative numbers is not defined and we want to be safe, we can say that if n is equal to 0 or if n is less than equal to 0, we return 1. So this is what we normally call the base case. So in this case, the factorial is completely defined without having to do any further work. Now, if n is not less than equal to 0, then n is greater than 0. So if n is greater than 0, then we take the current number and we multiply it by the smaller factorial. That's exactly the definition given above. So this in turn, so if I take, say, factorial of 3, right, so this will result in 3 times factorial of 2. So that will invoke this function again, and this will give me 2 times factorial of 1 and so on. So factorial of 1 will give me 1 times factorial of 0. And the point is that factorial of 0 will now terminate and it will give me 1, because it says that if factorial is less, the argument is less than 0, less than or equal to 0, return 1. So I'll then get, so this 1 will now come back and get multiplied here. So I'll get 1 times 1. So 1 times 1 will come here and will come here. So then this will bring back a 2, and then 3 times 2, and this will bring back a 6. Right? So this is how the function will execute. We will talk about this more later, but just to illustrate that functions can very well call themselves. So to summarize, functions are a good way to organize your code into logical chunks. So if you have a unit of computation which is done repeatedly and very often done with different possible starting values, then you should push it aside into a function. If you break up your function, your code into smaller functions, it's much easier to understand, to read, and to maintain. When we pass arguments to a function, it's exactly like assigning values to a name. So the values that are passed can get updated in a function only if they are mutable. If they are immutable, any change within a function does not affect the argument outside. Also, if we use the same name inside a function as is found outside a function, the name inside the function does not in any way affect the name outside. So functions have a local notion of what we call scope. So there is a scope of a name. Where is a name understood? So the name inside a function does not exist outside, and vice versa. Also, functions must be defined before they are used, and this is a good reason to push all your function definitions to the beginning of your program so that the Python interpreter will digest them all before they are actually invoked. So if there are mutual dependencies, you don't have a problem. And finally, we saw that we can write interesting functions which call themselves, and we will see many more examples of this in the weeks to come.